Hey everybody, I'm Aaron, here with Hans, one of our engineers at FUTO, working on the FUBS project with me. And our guest of honor today is Byran Huang, who, I guess maybe let me introduce Byran. How we became, aware of him is we're working with the Rockchip 3588 chip, and all of a sudden one day we see somebody has actually created a properly repairable Rockchip laptop as a kind of like skunkworks project while in high school. It was Byran Huang, and so we gave him a fellowship. So tell us everything that tell us all about it, I guess, right?
Well, thank you for introducing me, Aaron. So in my high school year, I created this laptop from sort of like a dare from my friend who was like, it'd be really fun if you just made a laptop that ran on solar panels or something like that. And the idea of the laptop really hit strong. I'm like, that could be a very interesting thing. And like something that's always guided me is this open source advocacy movement towards open hardware and repairability. And I feel like as the technology grows in complexity, there's that obvious need to make them more compact and more highly integrated, but that also reduces their quote-unquote repairability. And that's what all the big companies quote that they're trying to do. And it's like, oh, sorry, we can't repair it because it's just too integrated, or we have to make it waterproof, or we have to make it make it more robust. But in the end, I wanted to show that you could do something that was resembling similar performance and similar usability to a modern thin light laptop while still having all the necessary parts of a repairable laptop, whether that is having a fully modular shell, having your circuit board's completely open source, and still being able to fully use it. Because I know there's other laptops, like shout outs to the MNT Reform and Framework, and they take wildly different approaches to how they want to approach open sourceness and repairability. But I wanted to strike the balance between, okay, it still looks like a modern thin light laptop like the Framework, but it is all open source in the same sense that the M1T Reform is. And I'm not doing mass production like either of those, and that's a whole different challenge, but that's something that I really wanted to target. Yeah.
It's funny you should mention the MNT laptop, because we actually bought one of these. We were one of the first people who bought one of these.
Wow.
So yeah, this is it.
I've actually never seen one in person.
Unfortunately, it doesn't. The battery doesn't work on it, so it has to be plugged in. But yeah, it's kind of neat. It's kind of neat. It's got the Rockchip inside.
Yep.
But
it's very heavy.
The sad thing about this is, I think it cost us like €1,000, at least €1,000, and they weren't gouging us. It's just like, unfortunately, that's what it costs to put something like this together when you're not doing it at mass scale.
Definitely.
Yeah.
It is very well built, and it does feel like a laptop, right? But again, it's very thick, and obviously that's a result of their open repairable hardware. What I'm saying is that I guess my philosophy when I came to design the laptop was, they have these batteries for repairability and safety. I don't think that I could have actually shipped my laptop out to anyone because the batteries I had were, I think they were not UN8 tested yet, and so and of course if I were to actually sell the laptop, I'd have to go through so many hoops of regulation and get it certified with the FCC and everything. So and also this uses a thicker, for example, this has a thicker DIMM socket, I believe is what it's called, for the SOM to slot in, and that's a higher profile than my design. And also, to make it more repairable, they have a full copper heatsink that's directly on top of the RK3588. For mine, I designed it specifically so that it wouldn't be passively cooled. I actually had heat pipes, and the actual heatsink contact was only a millimeter thick because again, it wasn't a lot of thermal mass, and I had thermal pads that would lead out into thermal pipes that would come all the way around onto fans. And so I did everything I could to thin it out, but that also made it again harder to repair because let's say something actually broke on the main board. Of course you can repair it because it's open source, but most people probably just buy a new main board, and that's obviously not what they're targeting. And so I just think it's completely different design philosophies, and a lot of their thickness actually comes from the battery. So
Cool.
Yes. All right.
Cool. So, tell us some of the challenges I think that you had, why don't we get like I guess maybe you have some more insight now in terms of kind of why we can't have nice things like can you put yours into mass production or not, do you think, or could a company maybe go run with it at some point?
For sure. I think this first revision was totally geared towards a this first version was totally geared towards get it done as fast as possible while getting all the goals I needed to accomplish fast. And that's something that I was trying to focus on the entire time. So in the end result, what you see in my video and with Linus, that there's like Kapton tape everywhere, there's wires like all over the place. And that was purely because, okay, I mean, one thing I don't tell people often is that like it was a school project and the school was like kindly funding it, and I had until it was actually a day before my birthday to present the project in front of the school. And so if I didn't get it done then, like I would have realistically like not failed my project, but it wouldn't look good, and I would have just pulled up to the presentation with nothing. So the laptop, a lot of it was geared towards, can I get it done from starting it in the summer to finishing it before November? And so I put a lot of effort into parallelizing the chassis and the board design work. And I was just talking to a friend, and I told him that I separated out the digital components, like the main board versus the power board for the battery distribution, because I wanted to like when I got bored or got sick of debugging one of the boards, I could work on a quote unquote completely different project. And that would like sort of cure my engineer's block, however you want to call it. So yeah, that was one of the biggest challenges. And regarding why we can't have nice things, I think that like I would argue that MacBooks and like Apple's products are the pinnacle of like hardware engineering, but that doesn't say that they're repairable or they're good quality. They're good quality in terms of their hardware ability. But when it comes to being able to repair the laptops, there is a certain sense of like, for me, the cables kept disconnecting because they were sometimes soldered on, and like Apple would have brackets on top of their connectors. And those are things that I feel like are totally fair to put on laptops. But I feel like there's this urge or there's push to make it very sleek and hide all the screws. And also like especially putting screws under like tabs or putting them under stickers to hide the screws, I feel that's unnecessary. And I think someone like Teenage Engineering does a very good job of doing the contrast or nothing, where they would expose the screws and put it as part of the design language. And then going about the software part, I feel like that's more inexcusable per se, because as I'm taking a chip design class right now, and I really see the point of using BGAs and these incredibly complex packages and also underfill in chips, because as you're doing heat stress, the BGAs, which are necessary for the density of the chips and the packaging of the IC itself, would deflect under the heat stress. And so there is use and there is a justification for underfill and BGA for the technology that we use today, but I just don't see the same case for software. Like there's really no need to make your software so locked down like Apple has done with their recent releases.
So what I mean, speaking of software, I mean, talk to me a little bit about just how you see Rockchip and this ecosystem. Rockchip is making chips that are kind of intended to be in TVs, intended to be in phones, right? Is there a future for Rockchip as like the driver for a laptop, do you think?
Yeah, I think with this RK3588, I know there's the Gembook, the Cool Pie. There's a bunch of names that it goes under, but the Chinese-made RK3588, like literally just a very like Chromebook-esque laptop that you can buy for like $1,000 or so, and I think maybe even less, right? I think that's a great argument to say that an RK3588 right now, even like a quote-unquote hobbyist ARM course SPC could do all the daily tasks you'd want it to do, right? Google Docs, watch videos online, type up even edit some videos. It has the hardware it has the hardware encoding and decoding and a GPU to do all those things, even like play Minecraft. I mean, I remember I was using my laptop to play Bed Wars with my friends for a computing club, and it didn't overheat. It was perfect. It was actually pretty good. I could like pull out my wireless keyboard. It was wireless removable, so I could like take it out of the laptop and I can put the laptop a bit further back so the keyboard remains cool. And also I brought a mouse and I just plug it in with the actual full size USB port, and then I could just play video games for like at least like 3-4 hours. I didn't play for that long, but the battery life didn't go down that much. And in terms of the future, I definitely see that, especially with the RK35 or 3688 release, their new generation that, God knows how long that'll take. But with that release, I do see Rockchip getting more mainstream. And another chip that I see a lot of interest in is like both the Xiaoxin, which is the x86 competitor, I think funded by VIA, and they broke off, and there's a bunch of that. I don't want to get into politics of it, but I just think it's very exciting to have a third x86 player. And also the 6P1. And so that's the first, like, what RADSA at least advertises as the first open source ARM v9 chip. And I do see a lot of potential in the sort of next, like, sideline competitor underdog sort of coming in with a lower priced and more open chip than, for example, Apple. Like, if I Apple sold chips and had documentation, of course I'd do that in a heartbeat, even if it was BGA and it was incredibly hard to solder and all those things. The performance for what I get out of those would be just astronomical. But I do see that, like, because Rockchip still targets this heavy TV box, set-top box, sort of multimedia or like in-car industrial use, they don't support single-board computers that much. It's sort of like their hobby project, because I can only imagine like only a slice of their income comes from these hobbyists buying single-board computers, and a lot of it comes from maybe some mass-produced cars using it, or some set-top boxes using the RK, blah, blah, blah. And they have like a huge line of like multimedia chips. So I think that's where they're really targeting their effort, which is a huge disappointment, because like there's a lot of drama about people quitting software development on these SPCs. So I think that's a place that really needs work.
Yeah. So I mean, with FUBs, Hans has been working with the Rockchip, trying to get our FUBs project working on bare metal. I think it'd be cool to like hear you guys just talk about kind of like what that looks like in terms of, there's people trying to get Linux working on this that's open, right? We're trying to get FUBs working on it when it's open, and like kind of what the challenges are, what's happened. I know there's been some drama with like people getting burnt out, like. I don't know. Do you want to talk about kind of your thoughts?
Because like one of the goals that we have with FUBs is to be able to have like a small development-focused operating system that can come up basically instantly. So like we don't need to worry about UEFI and other stuff that needs to step in between. Like most of the time we turn a computer on, there's a lot of things that have to be initialized, and we want to be able to do it very quickly. But that means that a lot of the prior art of other people doing stuff with Android and with Linux is stuff that we can't use. We have to do directly what's needed. And something that we found when we were working with like Rockchip, when we were working with the Rockchip SoCs, is the documentation was very hard to access, and it was not very good. Like, it was not very accurate. There were a lot of problems. And getting stuff to work on the Rockchip chips has been difficult compared to, say, getting stuff working on x86.
Yeah, I definitely think that comes down to their target sector of like a very non-Western market, especially their developer community. Mm-hmm. Like I got most of my information off CSDN, which is a forum for like Chinese developers to post a bunch of code and write blogs. And it's like I don't know, maybe like EEV blog would be a close representation, where they just post a bunch of stuff, and like, maybe like Medium or Substack.
Sure.
And you can just search up a word, and you can like get a bunch of blogs or a bunch of data sheets on that topic. And like those resources aren't present for the US or Western or just non-Chinese speaking developer working on Rockchips.
Mm-hmm. That makes a lot of sense. Yes.
So okay, I mean, my understanding is, I mean, we can get Linux running on these, right? But Debian won't even consider that proper Debian because of as binary blobs. Is the reason why Debian doesn't say that the ARM, like Armbian is one of our grantees, right? We work with them, and they try to get Linux working on these things. I'm just kind of curious, what's that like getting Linux working on these? Like, why doesn't Debian have an official Rockchip release?
Yeah, throughout my laptop design, I wanted to minimize my software workload, so I can't speak heavily to the exact situation, but I can only imagine that Rockchip had done like their in-house development for Linux only for like kernel 5.xx and not 6. And so when it comes to like, obviously they have their in-house developers with the actual proper documentation and the engineers to support it, and then the community was left to develop later on with like 6.xx and Collabora, I think that's how you pronounce it, is doing great work with reverse engineering and implementing all those features, but that takes time. And I think that the open source community just has this this inherent like glass ceiling of like, you don't have the documentation to do the work you need to do. And like, if there was an engineer that you could just phone up and be like, oh, like, what is the steps to implement this, that would make it so much easier. But I just think there's a divide in how that works, and I don't know why it is, but I definitely something I've noticed.
Yeah, I mean, it's something we're trying to get better if we can.
I mean, I imagine that like with also what you said with the having a focus on like set-top boxes and like car radios and stuff like that, like that's a different kind of workload altogether. And it's probably like Android is usually suited better for those things than like Linux is. So there's probably more focus there, I would assume.
Yeah, I think I've felt that as well, and also like set-top boxes don't need bleeding edge performance or even the latest kernel. I think a lot of the set-top boxes that run on Rockchips are still running like whatever the original fork is off the Linux tree for Rockchips, because like the manufacturers of them, they don't need like the latest kernel or the latest security. They just need the cheapest product out as fast, like as mass producible as possible.
Okay, let's move on. Let's talk about your fellowship. So we gave you a fellowship, FUTO is sponsoring you for. We were like, what project do you want to do? Like, you can pick anything you want.
Yeah.
Tell us about what you decided to do.
Yeah. So I ended up working on a mouse project, and I'm still working on it to this day. And I've talked about it a little bit. Just in the end of my last video, I like teased it a little bit. It's an ultra lightweight mouse that hopefully doesn't have a battery, and that's something I'm really working towards. And I'm working against like the limits of physics there. But it's just I'm trying to tackle it as more of an engineering feat. And the reason I want an ultra lightweight mouse in the beginning is that I've always liked PC gaming. I've never been really good at it, but it's a very interesting challenge to make a mouse as light as possible, and that's to minimize the inertia when you're aiming for competitive shooters or any other game, that maybe even like OSU, like just games that need really rapid mouse movement and very precise mouse movement. And so I want to build a mouse that is full size, so you could grab it like a regular mouse, not one of those like fingertip grips that are like microscopic, but an actual full size mouse that would be less than 15 grams and would have the highest performance sensors, firmware, the lowest latency, even over wireless. I want to get as close to being to have the latency of a wired mouse as possible, and have all the fancy features that are considered like modern mouse would have. And like I've gotten some of the firmware working, the sensor firmware is working now, the wireless communication is working. I have a new sampled chip from Nordic. Shout out to them. They've been very kind in supporting my new firmware development with their new chip, and so that's able to give me about half the latency of one of the predecessors, like the other gaming mice. I hopefully would in turn have like at most like a 3/4 of the latency of a modern, like an Amazonable gaming mouse right now, and then a carbon fiber shell, and just like doing everything I can to minimize the weight. I'm trying to approach it with the like gram method, where I remove every single where I try and shave weight off every single part of the mouse to the point where instead of metal screws, I'm going with this I don't remember exactly what it's called, but it's some very specific PEEK-like plastic mix from Mitsubishi that is very similar in strength to metal, in terms of like tensile, not tensile, like the rotational strength. It's getting a little bit lost. I'm not a mechanical engineer, but just like trying to shave weight as much as possible, and then hopefully having a bunch of options to charge it and just provide power to the mouse, whether that is RF power harvesting, resonant inductive power coupling, just regular power, wireless power transfer, whether that's into a supercapacitor or a lithium-ion battery, and just I want to approach it with as many methods as possible. And I'm just trying to show like you could choose actually. Like, given like the resources, you can intelligently choose what works best for your setup, right? If you just never want to charge your mouse, like you could just go with an RF power harvesting method and never have to charge it again. Or you can go with a battery and have it last for very, very long on a single charge. And you can choose how big the battery has to be. It doesn't have to be set to a certain size. And if you go with a supercapacitor, you could go, maybe 2-3 hours on a single charge and swipe it to the side, and there's contact pins, and you can just charge it right up. So yeah, that's some of the ideas I'm working on. Actually, I'm not sure if that's.
I actually wanted to ask you a question.
What
kinds of sensors are you using in the mouse? Because I imagine with like having those ultra low power requirements of not wanting to have much of a power source inside of the mouse, what kinds of sensors have you found like work best with your design goals?
Yeah, so I'm still using this like quote unquote state-of-the-art mouse sensor from Pixar, so the PAW 3395, and that consumes, if I recall correctly, about 10 milliamps at like 2 volts or so, and so that gets you, like maybe a bit less. I think my total power budget was about 50 milliwatts. And so even with the state-of-the-art sensor, it only consumes 50 to 100 milliwatts of power.
Nice.
Yeah.
It's like an optical sensor?
Yeah, it's an optical sensor. I think it's called
Okay.
VC cell, like selective laser projection, what Pixar specializes in.
Cool.
And I'm just trying every method to save weight. But like I was also considering, cutting down the power to get a lower performance, or like just saving power with a more power efficient sensor, but that would cut back on performance. And I still want to chase 8 kilohertz polling and all the things that like a modern like top end gaming mouse would have.
Right.
Yeah.
Because like you want to be able to move that mouse whenever you need to. You expect that when you move the mouse moves.
Yes.
On the screen.
Yeah, and I want it to be like, even if you pit it against the top line mice, you will get as good, if not higher performance. And of course, all the electronics, all the firmware, and all like the steps to make it will be open source. Rest assured. And I don't think that's ever going to change. Yeah.
So I'm guessing you're using Bluetooth for your protocol here.
That could be one option.
Okay, good.
Yeah.
That's cool because I would guess Bluetooth is probably not optimal.
Yeah, Bluetooth isn't optimal, but so I'm trying to go for a tri mode. And so it could be Bluetooth, it could be 2.4 gigahertz proprietary, and that's proprietary in hardware. So the software implementation will still be open source. It's just the chip has its own packet transfer protocol called Enhanced Shockburst from Nordic, and you can transfer like a 4-byte packet in very low latency from a receiver to a transmitter. So you have a dongle. That's high-speed USB, and so you plug in, it's still 8 kilohertz, and this is what the top-line mice do now.
Okay.
And of course, there's still going to be USB on the mouse. I don't think I think putting on a full USB connector will actually add a lot of weight. So I'm considering doing either just very low weight data transfer, very low weight wires for data transfer, or doing optical, like a fiber optic strand, because they're actually very flexible if you go down thin enough.
Yeah, so I mean, you graduated from high school.
Yes.
Congratulations. And
Thanks
now you're
so much.
at Yale.
Yes, I am.
In computer science, I understand?
Or probably electrical engineering.
Okay, so you're maybe undecided. Okay.
Yeah, I'm
cool.
not very decided, but
Okay.
this past summer working at Neuralink has also interested me in a lot of neuroscience and psychology. I'm taking psychology right now, and like it's been very fun to sort of explore my options. And I'm taking a chip design class, and that's teaching me a lot about like VLSI and just like very nuanced decisions in the chips that we use today, and building up from that in a fundamental standpoint. So yeah, it's been great.
Awesome. Is there anything else on your mind that you want to talk about?
It's a great question. I mean, first of all, thank you guys for having me on for this interview. It's very much of an honor.
Well, we appreciate, the reason why we reached out to you is because, there's engineers are actually, I say this sometimes, engineers can be the worst because everything that we complain about with our closed ecosystem is actually being done by a very obedient engineer working for big tech. Mm-hmm. So the fact that you were already doing kind of like things, trying to keep them open. We really wanted to do everything we can to encourage you and people like you to, fight the good fight, to like give the consumer what we deserve from our technical products.
Yeah, for sure. Yeah. I guess I'm just gonna keep trying to get the mouse working, and I'd say that it's harder. The mouse project has been way harder than the laptop, because the laptop has a very clear objective and guidelines, and like step A, B, C, like make the chassis, make the main board, make the audio, make the power board, and make the display work, and put them all together in the end. The mouse, I feel like, is very different, because it's not like I can just flash on this magical mouse firmware like Linux, where I can just plug it in and it'll boot up with a display and all the things that I need for the operating system. Like, if I had to do the entire operating system development for the laptop, that would have been insanely difficult. Like, there was no way I was getting that done in 6 months, and probably wouldn't have gotten done in 6 years if I was basically doing what you guys are doing. But like, I was trying to get a graphical user interface in and running, and like supporting a 4K display. But here, like the mouse, there's no like open source set of firmware that is completely open, and it's like, here you go, like here's the fastest, like highest performance firmware that you can possibly get. There's ZMK, but that only supports Bluetooth out of the box. There's some forks that support enhanced shock burst, which is a 2.4 gigahertz dongle. But I also want the firmware to be readable, because I want like the projects that I make to be a learning opportunity for people, and that's something I really want to put a lot of emphasis in, because I learn all the electrical engineering and software knowledge that I have sort of online, or like listening to people talk about it, or seeing people work on it, rather than like I've never actually had an engineering class until like this semester, and even then, like these classes don't point anything towards like the stuff that I do and stuff that I work on. And like, I want to show people, like, for example, if some other person was curious how like an 8 kilohertz mouse was done, or 2.4 gigahertz, or like RF, how all this stuff was done, they could look up my repository and like see it in context of being in use. And I also want it to be easy to understand. I don't want like a super complicated like a multi-queue, like crazy amount of interrupts, and like this insane structure just for the mouse to work. And I see the point with ZMK, because they have to support so many wide devices. They have so many different key bindings and macros. ZMK is a Bluetooth firmware for keyboards, similar to QMK, that I've also worked on extensively. And like, they have a different approach than what I want to do. And like, I want everything to be as readable, as simple as possible, while getting the same performance, because I want, in the end, someone to be able to look up the repository and tear it apart and really figure out, oh, this is how it works. Because like, that's how I want to learn, and that's how I like learning, and that's how I hope I can inspire other people to learn.
Yeah, I mean, it's even, to me, it even goes further than that. So I believe it's a basic human right that the computers in our lives that we have in our pockets, they should not be extensions of Google's power.
Yes.
Right? They should be our computers.
Yep.
And so, like, everything you're doing to help make that happen, we appreciate so much.
Thank you. Yeah.
All right. Thank you, Hans. Thank you, Byron. Everyone out there, if you have ideas on how to make this better, let us know. Thanks. Bye.